Okay, we're going to write an algorithm to convert a string that represents a Roman numeral into an integer. So if we had like M, C, M, X, C, then that would be, N is 1,000, so it would be 1,000. CM gives us 900, so 9, and XC is 90, so it would be 1990. Okay, so to do this, we're going to store everything in like the different Roman numeral characters in a dictionary with their corresponding value. So we'll have map, that's going to pretty much be I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. Okay, so what we can do, we'll get started. Just call it get integer, and it's going to take a string of Roman numerals. First, we can test it out and see if rn dot length equals 0, we want to return. Well, we can actually, we'll throw an exception. So okay. Otherwise, we can go into our algorithm and we're going to want to create our dictionary. So we can make a dictionary of chars and ints. You can just call it map. A new dictionary of chars and ints, and we can actually initialize that right away and get I and 1, V and 5, X and 10, L 50, C and 100, D and 500, and then we've got M and 1,000. Okay, so there's our dictionary. We're going to also want to keep track of a sum that we are going to, as we step through the string, we want to add these to the sum as we look them up in the hash table. And actually, I think I'm going to put that up at the top so that make a little more room. Okay, we'll put it up at the top so that we can kind of use it for more globally within the function. So we'll do int sum, and I'm going to just start it with the first character in the array's value. So map it rn of 0. Okay. All right, and then we're going to have our dictionary, and then we need to, I just realized we can't set it to map. We'll do it 0 here. And then we will have to set it in after we've made our map. So sum equals map at rn 0. And then we also need to keep track of our current value. And then we want to always pay attention to our previous value, because this is how we can tell in those cases where you have like IV is 4 and IX is 9 and things like that. Okay, so we've got those. And then we'll just get into, we're going to loop through our string one time. Plus, okay. So then let's put in a little thing so that if there's like a wrong letter or something that's not even part of a Roman numeral, we can catch that. We'll just return 0 since 0 is not a valid Roman numeral. So that works. And then we'll go ahead and we want to set our current value equal to the value that we're on. So R will be map at Rn of I. And then we can add that to the sum. Okay. Now we have to make sure we test for those special conditions, like when there's an I in front of an X or something like that. So let's first make a previous num set to, or previous value, I should say, set to R of n at I minus 1. And that reminds me that, oops, map at R of n. Map at R of n of I minus 1. Okay, that reminds me, we can start this at 1, first of all, so we don't go out of bounds with our previous check, and second of all, because we already set sum equal to the first value in the map, so we can start looking at the second value. And then we can say if the previous value is less than the current value, then we know we have that special case, because otherwise they'll always be larger than each other. So if previous value is less than the current value, then we know that we want to subtract that previous number from the sum, but we already added it, so we actually need to subtract it twice. Okay. And then that should take care of our for loop and our else statement, and we can return sum at the end. And the one thing I think I want to do is go ahead and make sure that we convert this string. In the case of, let's say it was lowercase letters or something like that, we could either add all the letters again to our map in lowercase, so we can cover both, or we can convert everything to upper. So I'm going to go ahead and just say, I'm just going to go ahead and convert it to upper in my else statement. So I can say R and dot to upper. This way, it's only going to look at uppercase for all of the cases. Okay, so let's go ahead and walk through this. Get it to where it's all on the screen. Okay. Good. I already have a map kind of filled out here, so I'm just going to use that and get kind of an example going. MCM LIV. Okay, and this is the number 1954. Okay, so we'll see if we can get that result going through this algorithm. So we're going to need to keep track of, we've got our dictionary, so then we need to keep track of sum and current value, previous value, I think that'll do it. So we'll go ahead and number these as well, so it's easier to go through it. And that's not an H, that is a 5. 5. Okay, so we go in, we've got our dictionary, and everything is going to be converted to upper if it isn't already. It already is. And then current value starts at 0, previous value starts at 0, and sum equals map at Rn of 0. So sum Rn of 0 is M. We go to the map, so sum starts at 1000. Okay, then we get into our for loop. I starts at 1. So we go, if the map doesn't contain the key at Rn of 1, which is C, it does. So we go in, and that's 100. Current value equals map at Rn of I, so 100. Previous value equals map at Rn of I minus 1, so that would be 1000. Then we come in, if previous value is less than the current value, which it's not. Oh, we missed a line here. So sum plus equals current value. So now sum is 1100. Okay, 1100. And then we go in, and if previous value is less than current value, we would do that, but that's not the case. So I plus plus, I is 2. All right, so we come around, 2 is less than Rn dot length because that is a 6. And if map doesn't contain key at Rn of I, well, it does because that's an M. So then we say current value equals map at Rn of I. So current value is now 1000. Sum plus equals current value. So now we're at 2100. And then previous value equals map at Rn of I minus 1. So that it would be at C. So previous value is now 100. And then we go in, if previous value is less than current value, which it is. So we go in, sum minus equals 2 times previous value. So previous value is 100. So 2 times 100 is 200. So 2100 minus 200, sum is now 1900. All right, and then I++, I is now 3, 3 is less than 6. Come in, if the map doesn't contain the key Rn at I, which is an L, so map does contain that. Current value equals map at Rn of I, so map at L is 50. Sum plus equals current value, so 1950. Previous value equals map Rn of I minus 1, so we're looking at map at M, which is 1000. If previous value is less than current value, and that is not the case, so we keep going, I++, I is now 4, 4 is less than 6. If map doesn't contain the key Rn of I, which is the I, and map does contain I, so we come in and we say current value equals map at Rn of I, so that would be current value is 1. Sum plus equals current value, so 1951. Previous value equals map of Rn of I minus 1, so that would be 50. If previous value is less than current value, which it's not, so we don't worry about that, and we keep going. I++, it's 5. 5 is less than 6. If map doesn't contain the key at Rn of I, which is a V, and it does contain it, we don't worry about that. Current value equals map of at Rn of I, so map at V is 5, so current value is 5. Sum plus equals current value, so 1956. Previous value equals map of Rn minus 1, Rn of I minus 1, so previous value is 1. If previous value is less than current value, which 1 is less than 5, sum minus equals 2 times previous value. So 2 times previous value is 2. So we take 2 and we take 1956 minus 2 is 1954. Okay, and then get out of that. I++, I is now 6. 6 is not less than 6. So we get out of our for loop, we go to our return, and we're returning sum, and sum is 1954, which is indeed what we were hoping for. So this entire solution is done in O of n time and O of n space, since we added on, well, and it's not really O of n space, it's really a constant space because we're only adding the hash table with a limited number of elements. So we can probably just call it O of 1 space, which is a constant space.